I recently got to read Brian Greene's The Elegant Universe book, and there were a lot of things I liked about it. In this video, I'm going to talk a little bit about my thoughts on the premise of his book, which is the theoretical usefulness and potential truth of string theory, and then also offer some reasons why I think it's just a great book overall. So, string theory is super compelling, and I learned a lot about it from this book. I think the biggest virtue of this book is that Greene does a super fantastic job of writing and communicating science in ways that are interesting. He uses a lot of like narrative style where he talks like in terms of story form, but when he doesn't, he also can communicate the science in that's complex in readable ways. He would be a super good high school physics teacher. I know he's a professional like theoretical physicist, so he's not going to be doing that anytime soon, but I only mention that to say that he is a great teacher, and I'm really glad I got to learn from him through his book. String theory is super compelling because it's supposed to be a grand unifying theory about our physical cosmos. So on string theory, the fundamental units of the universe are not subatomic particles like quarks, but they're actually one-dimensional filaments called strings, and these strings are tiny. So as Greene explains, these strings are said to be about as long as a Planck length. So Planck length is super, super small. As he says, if we were to expand the size of the universe or like scale it, if we were to rather scale an atom to the size of the visible universe, one string would be about as long as an average tree on Earth is tall. So it's like way, way tinier than even a single atom, like astronomically tinier. And that's just really cool. These strings are said to be like all the same length. So what matters isn't their length, but what matters really is the oscillation, the energy level of their vibrations. So there's four fundamental forces in physics, and these strings, their vibrations, are said to account for all four. So ranked in order of strength, we have the strong nuclear force, then we have electromagnetic, weak, and gravitational forces. So a string that vibrates with a higher energy level is going to have or going to correspond to that strong force. And then a decreasing energy level is going to correspond to each of those three other ones. So I thought that was super interesting to hear about that theoretical usefulness of unifying all four forces, which is something people have wanted to try to do forever and have not been able to do successfully. String theory not only is postulated to resolve those four forces, but is also postulated to resolve the conflict between quantum mechanics and general relativity. One of the wild things about each of these models is that they work really well at an extreme scale. So general relativity works really well for super big stuff like galaxies or the entire universe, but quantum mechanics works really well at super tiny scales like subatomic particle interactions. But as they're both stated, they're actually incompatible with each other. So one thing that's cool about string theory is that it's said to actually resolve those conflicts. And I think the fact that if string theory is true, the fact that it can subsume all four fundamental forces under it and solve that conflict between quantum mechanics and general relativity is super cool. So I really loved learning about those reasons why some people do believe in string theory. There are some really compelling reasons to consider it. So for example, there were physicists before Greene who realized that there are some reasons to potentially accept some of the presuppositions of string theory. So one of those I guess not presuppositions, but one of the things that string theory really necessitates is the existence of tiny spatial dimensions beyond our three spatial dimensions that are super familiar to us. So the idea here is that these super tiny spatial dimensions are too small for us to observe right now with our technology, but they're actually where those strings are housed. And if that's true, that's really interesting because it means that those dimensions are really dictating the structure of the entire rest of the universe, even though they're super tiny with the strings that are contained within them. So, there are some things there that are worth thinking about. I think there are some oddities with string theory as well. Like, for example, the one weird consequence of string theory, if it's true, is that it implies that there's actually an infinite number of subatomic particles. So each vibrational energy level of a string corresponds to one subatomic particle. And the fact that there's actually an infinite gradation of vibrational frequency levels, as Greene notes, implies that there are actually an infinite number of subatomic particles. But this is a little bit weird for me to conceive of. If it's true, that's fine, but it's a little bit, I think it's actually a reason to potentially doubt string theory, or at least as it's conceived in the book. That's a weird thing. There's other weird things, but overall, I think it's super interesting. One thing I like about Greene's approach is that he's not saying this is 100% true. He actually has the intellectual humility and honesty to say, like, straight up, like, hey, like, we don't know if this is true. We can't experimentally verify it right now because we just don't have instrumentation that can possibly look at Planck length sized things. Like, we just don't know. So at this point, it's theoretically useful, but we aren't for sure whether it's true. And I like that a lot. Overall, I give the book probably 8.5 out of 10. Really good. Writing is excellent, and it's compelling the whole way through. I think there are just a few things that could be improved, but honestly, it's not like a huge deal. I think it's just really good, and I'm glad I got to read it and enjoy it. If you've read it, let me know what you think. If you haven't, like, maybe this will give you an opportunity to maybe take a crack at it. I don't have a physical copy because I read it on Kindle and Audible, but otherwise I would show it. But yeah, those are just some of my thoughts. And yeah, thanks for watching.